Bro, feel free to. First of all, thank you for being here. I'm recording. Thank you for being here. This is very nice of you. There's a lot of very useful information. And feel free to share your screen, and just
Yeah.
go through what you prepared. So even if not a lot of people join right now, we can always have this on YouTube and more people can learn from you. Okay?
Yeah. Thanks for having me.
Thanks, buddy.
Um, I share my screen. Okay, I should be live now. Nice. So Solhunt, essentially what is Solhunt? It's a tool for security folks like auditors or developers who write Solidity contracts, and they want to detect vulnerabilities or do some checks like style issues or gas optimizations in their contract. And they wanted to do it fast without too much knowledge about programming. Um, so essentially, this is a static analyzer like Slider and Solstat. Slider is the old one. It's very established. It has a lot of tools attached to it. And Solstat is a bit more recent. Maybe you guys don't know it compared to Slider. It's written in Rust. It's quite similar to Solhunt, but it has some differences as well. And so my aim in this talk would be to show you what are the differences, and hopefully do a little code, live code view to show you how to develop detection modules in Solhunt. Now the thing is that when you code live, nothing works. So yeah. So the main issue with Slider is that it might be slow. It's written in Python, but it's quite fine. The time that was the time that was shown in the GitHub page was about 1 second per contract, which I could reproduce. Solstat and Solent are two static analyzers written in Rust. They are both much faster. And so the issue with Slider and Solstat is that they are fetching the node. So let me explain a bit more. These three tools are compiling using the Solidity compiler, Solk. And one of the steps of a compiler is to give some insights about the code. So you could just don't compile it and apply some rejects and stuff, but that wouldn't work very well because you have to maintain it a lot, and there will be a lot of edge case. So what compilers do is that they return an AST, so it means the abstract syntax tree. And what is it essentially is that it's a bunch of nodes that designate the variables, the function, the contract, the pragma, everything in a smart contract. And what you're going to do is that you this AC eventually convert it into another thing that would be a higher resolution, and then apply some modules on it. And so the issue with Slider is that it's not too easy because the code architecture. And the issue with SolStat is that they are fetching the nodes compared to Solent. And the reason is that for Solent, I based myself on a PR that was made from Anjag on the ETS repo. And this PR was about I think the AST nodes. And so I've made some fixes on this PR because I could say nobody would replace. And it also an issue with the component parts, like the AST and the AST. And I also tried to push it to open and progress with the fixes, but it was the creation of the ETS repo and the Foundry repo, which was relying on it a lot. And it was a bit of a mess, but hopefully we get merged in the future. And what I've done also is a visitor. And what is a visitor is that it's a code that go through all the nodes and notify the implementers of the thread that it's going to visit a specific node. And when you write detection module, it's gonna check what is in this node, and depending on what is in this node that you may want to detect in your code, you're going to add some findings, and then at the end they are going to be formatted with the GitHub link, so you can access it very easily. A view also of the code with the line and cool stuff. So here on the top left, it's a view of a slider detection module. On the top right, it's Solstat, and on the bottom, it's Solhunt. And as you can see, the issue with these two codes is that it's fetching the nodes. And the issue of that is that it's not a very scalable solution. And so what I came up with is using the visitor I've written. And what you're doing is that you're writing a function, visit function definition. The node name is the function definition, you can see here. And you're writing some condition, and if those are right, then you're going to push finding. So here the finding is the ID 0. So it's this one to tell that X because of Y. And I run some benchmarks. You can see that it's pretty fast. This was run on a wall code base. It's Biconomy. You may know it. It's account abstraction. I'm not affiliated with them, but I don't know. I wanted to run it against it because the Code Arena made a contest about economy, and I thought that I could try test my modules against live contests with other people's submissions. And so the main issue, which is an upgrade axis, is that the state module is painfully slow, 1 second, because it's taking. It has a lot of visited functions, and it's a lot from the AST, and it just not very optimized. And once I will optimize it more, it's gonna be much faster. And thanks to Rust, you can just parallelize everything, and the wall detection plus compilation should be really quick at the end. So the cool thing with Solent is that you can write unit testing and integration testing, similar to these terms in software development. Unit testing is testing a detection module on a specific line. So for example, you are using an assembly block and you say that using assembly is bad because it's super dangerous. You're going to write a mock contract that has an assembly block, and you're going to say that the assembly block is at line 5, for example. Then you're going to run the tool, and if the line found for the assembly block module is 5, then you won. Um, the other cool part is integration testing. So as I said earlier, I run benchmarking test on the Bioeconomy contest. And so what you can do is that you can just pull a whole code base and test for the location of findings on specific line, and it's going to do exactly the same as the unit testing to make sure that you have much less false positives as rather than if you just wrote unit testing, for example. And now I'm going to try to code live to show you how to write a detection module. So of course, it's not going to be complete. It's just a demo. So, for example, there is a contract called mule, which is just multiplying a value by 2. And there is a gas optimization, which consists of using a left shift, which is going to shift all the bits to the left one time, rather than multiplying a variable by 2. And so what I will do usually is that you define the build visitor macro, then you write the findings, the ones you want to find. So this one has an ID of 2. The summary will be, for example, use left shift, and the description is use left shift rather than mule because it needs gas optimization. This is our unit test. You're going to write a mocked contract, which is super small. And you hope to find that the optimization that the detector module is going at this line. And this line is 5, if I'm not mistaken, yes. And this is exactly what we are writing here. The line for finding with code module of this specific module is the ID 0 at line 5. Now we need to register it, the module, in this big array. I'm just going to copy paste this. Then it's called gas, and it's called math. Right, so now we just register the module. Usually that's the part that you just forget. You run the test and it cannot find anything for some reason, but that's just because you didn't run it. So what you can do is that you can pass the debug flag. You call it debug, and you write true. And you are going to just test as it was a Rust test. So it's called mule AMA. And what it's going to do is that by passing the debug flag, it's going to show you the full AST that I've talked to you about earlier. And hopefully we're going to find something that it is related to this expression with a mule inside it. So it seems like it's close to this. There's this. Okay, so here we have an operator, it's the mule. And the main node is, let's say, binary operation. So it's binary operation that we want to find. So what we're going to do is that we're going to define a function, and we can call it like this. Now the issue is that the LSP doesn't work very well in the macros, because it's very hard for the LSP for Rust Analyzer to reason about the macro. What I'd like to do is just debug print the node. Then we can run it again without the flag, or it's just gonna write the IST again, which we don't want, not clutter or eyes. And what it should do is that it should debug print the node that we were interested in. So now what we have is that we have this binary operation, okay, and the operator is a mule, okay. So we could just say if hero.operator. We can just push finding. Oh, nice, it find it. And source is the node we just found that we are going to clone because there's no reference to this value. And it should find it. Let's comment this. Import it. No, okay. Mm. But let me check views. Should be in the details things, which I not do right now. I don't know if you have some spare time at the end. So the issue is that I need to find this tag in the talk package, but you get the idea, I think. Now what we can do is that as this is the gas optimization, we can create a contract that will measure the time, the gas that you spend before the optimization and the gas after the optimization, and it's going to compare the gas after and before to just tell you how much you saved. And I think that it's neat for people participating for contest because it's going to write the report for you. So, for example, there is a gas optimization when you define the error from Solidity because the byte pushed, and this one is a value pushed stored in the memory. So you have the length of the value, which is this expensive. And what it's going to do is that it's going to deploy the contract from the gas method function and deploy the contract to and call the gas method function and compare the usage and then it's going to start in a database. The name is in 0 and Solidity starting from is the version in your I submitted to Colorina because it's right now. It's quite sad. But yeah. Now the maybe last thing I do are the integration testing. So this one are looking into the data. I'm going to show you how I implemented, for example, the Bay Economy integration testing. So what you have to do is to copy paste the Bay Economy repo into test data. And then you go into tests by economy. And what it's doing is that you write a testing function. Then you call this. This does almost the same as Foundry. It takes the this directory, and it's going to compile. I couldn't compile without the optimizer, probably one of the limitation because of stack too deep. And now you are going to asserting that it has a gas optimization, for example, at this location. Here you may use another thing related to code style, or it may have some kind of vulnerability that you may have identified. Now, what you can do is that you can write an easy gas optimization, which will have a low amount of false positives. But the issue is that when you starting to write something a bit more complicated, it may be a bit harder to reason about, and you may have more false positive. Um, um, for example, if you, I don't know, if you write some kind of reentrancy, you have a lot more complexity because you are assigning value to variables. And eventually, this may not be a reentrancy because there is a guard or something, which is maybe a bit more the role of dynamic analysis and this kind of stuff. Um, to
Really
guys
interesting, man.
bit on this later.
Interesting. First time
Yeah,
I'm
thanks.
seeing this kind of approach, of actually building a static analyzer, looking at an AST. So this is quite cool. Does anyone has questions?
Just ask in chat if you want.
Yeah, good one. Let me see if we have anything in the chat here. So Jet is asking, all gas comparisons are with what compiler optimization? So you test all the variations for the compiler?
Yes, so it's about the gas metering. So yeah, you write a contract from and contract to, and this is the versioning thing. So you just said that the it's going to deploy the contract from and to and measure the gas metering from this version. And I don't know if you can know this one is the same. Yeah, for example, this one is more than 0.5.0. And that's because some contract may not be, compatible, such as this one, because customs errors have been introduced a bit later in the Solidity compiler.
How long did you building that so far, bro?
I started pretty much when the PR got opened. So it was something like 6 months ago.
That's quite.
But I just kept it as a project.
Are you
Yeah,
taking contributions? So anybody go there and help you? Not yet.
yeah, sure. So it's called Solhunt. And I will be glad if you guys manage to write some detection modules and just open a PR to it. Maybe I can just send the link in the chat.
Yeah. That was really good, really interesting, really nice to see these kinds of research, And thank you so much for coming here. You have any closing thoughts? You wanna talk anything? Talk a little bit about yourself, or maybe give out your Twitter.
I mean, thanks for having me. It was really great to present my tool. Um, I'm gonna think about maybe making another talk about I don't know, some kind of tool.